Example 5, and this one is the last example we're going to do. So two infinite parallel lines carrying equal but opposite uniform charge density, uniform parallel planes, plus or minus sigma. Find the field in each of the three regions, 1 to the left of the both, 2 between them, and 3 to the right of both. So we have the situation where we have these two planes, that two infinite parallel planes. I'm just going to draw planes. And there's another one. And they're parallel, which means they never intersect. And so this one has a charge plus sigma, and this one has a charge minus sigma per unit area. And so we want to find the electric field out here, and electric field in here, and electric field over there. So we're going to do this using three different Gaussian surfaces. One is this Gaussian surface that kind of pokes through there. The other one is we're going to do the same thing on this side. And it pokes through there. And the last one we're going to do is this big Gaussian surface that goes through here, and it kind of extends out, and it goes through here, and then it pokes through the other side. Okay, so these three different Gaussian surfaces. So the total charge enclosed here is proportional to the area, and just like we found with the sphere, it's not going to depend in any way on the distance. And so the electric field out here is going to be equal to the charge contained here. So it's going to be, actually hold on a second, that's not quite right. Back up. The left plate produces a field 1 over 2 epsilon naught sigma, which points away from it. So this one has a field that points away from it. Let me draw field lines here. So this one points this way and this way. This one points this way and this way. Okay. So if we consider I've kind of gone about this, I've kind of got ahead of myself here, but basically the total flux through this surface has to be 0 because the total charge enclosed is 0. So we know the E field out here is 0. Okay, this one because it actually extends over here. Now this one is pointing the opposite way. Okay, so this one's pointing towards, and this one is also from this one is pointing towards there. So the E field is 0 over here and 0 over there because this one encloses equals 0. But this one obviously isn't 0, right? So the question is, all the flux must be going through this one surface, so this must be 2 times what we expect. The same for this reason. So inside here, the electric field is actually twice as strong as it would be if you just had one plane. And I guess this is further proof that planes, infinite planes, don't care how far away from you are. So that's example 5. Hope you've had fun. Thanks, bye.